Welcome to the Terry Lake Assessment and Design Project conducted by Hydrologic Engineering. We are a team of 6 made up of 3 civil engineers and 3 environmental engineers. The goal of the project was to analyze the Terry Lake spillway and earthen dam in order to develop design solutions to accommodate for high hazard dam regulations. Terry Lake is situated in northern Fort Collins, and with its close proximity to residences, it is highly important for the infrastructure to be able to withstand probable maximum flood conditions. Our first objective was to be able to identify key locations around the lake, being the locations of the spillway, dam seepage, tow drains, and neighboring highways. The locations of wind-generated wave damage were also identified to be used at a later date for erosion analysis. The first major step towards establishing remediation requirements was to create geotechnical and hydrological models of the areas of interest. Once all relevant characteristics of the dam were collected, we split into 2 separate teams to engage in the 2 modeling endeavors. The geotechnical team used the modeling software SlopeW and SeepW to model the homogeneous earthen dam, and to determine if a tow drain would need to be installed to lower the piezometric surface. It became apparent from the modeling that a tow drain would be necessary to meet regulations, so the process to design an appropriate drain was initiated. Using the National Engineering Handbook, the team was able to input the parameters of the dam and obtain the candidate filter materials and the pipe sizing, resulting in a complete and effective design of the tow drain. The efficacy of the design was determined by integrating it into the geotechnical models, where it was shown that a new and acceptable piezometric surface had been realized. With this being verified, the final design of the tow drain was then modeled in AutoCAD to clearly showcase the final specifications. Throughout the geotechnical modeling process, hydrology modeling was being conducted simultaneously. This team began by classifying Terry Lake as a high-hazard dam using the Decision Support System for Water Infrastructure Security, or DSS-WISE. Analysis was performed using this tool, which provided data about the population at risk and inundated area in case of a dam breach. Using this information, combined with regional extreme precipitation data, modeling of the basin in ArcGIS and HEC-HMS was performed to determine the performance of the spillway. Simulations for the 2, 6, and 48-hour storms were run to determine if the current spillway capacity can accommodate the probable maximum precipitation values. Results from the model showed a high likelihood of overtopping under the 48-hour storm PMP conditions, indicating that the spillway capacity would have to be increased. The current 300-foot-long trapezoidal spillway has a capacity of 4,780 cubic feet per second, and the outflow from the 48-hour storm was 16,521 cubic feet per second, indicating that the spillway length had to be tripled. 2 alternatives were identified: increasing the length of the current spillway to 900 feet, or transitioning to a labyrinth spillway. The selected design was to increase the length of the existing spillway, as the cost of concrete and installation of the labyrinth spillway was significantly greater. The new 900-foot-long trapezoidal spillway was simulated for the 48-hour PMP, and it was proven in HEC-HMS that it had the appropriate capacity and the dam was not overtopped. The final aspect of the project addressed the issue of bank erosion by wind-driven waves on the eastern shoreline of Terry Lake. Theoretical modeling of peak wind conditions established that installing riprap with the following specifications was needed to mitigate the shoreline erosion issues. Terry Lake has a variety of engineering challenges to be addressed, but through modeling and technical design, they can be overcome. With the hazard level of dams being determined by the level of loss of human life and property damage, a high-hazard dam such as Terry Lake should be treated with the utmost attention to detail, and that's what we at Hydrologic Engineering believe we have achieved. Thank you for watching, and thank you to Callie Bauer for being an invaluable resource throughout the project.